Well, we're going to continue our discussion of the big 5 traits today. And I'm going to talk to you about openness and intelligence, roughly speaking. So the first thing I want to do is put them into context. You need to understand where intelligence fits in the trait hierarchy structure. And so we've looked at this before, but you can break the big 5 into the big 2. Plasticity and stability. We'll start with stability here. And stable people are conscientious, high in stress tolerance or emotional stability, or low in neuroticism, depending on how you look at it, and high in agreeableness. And then conscientiousness breaks down into industriousness and orderliness. Neuroticism breaks down into volatility and withdrawal, and agreeableness breaks down into politeness and compassion. And then for the second major trait, you have the big 2 trait, you have plasticity, and plasticity is made up of extroversion and openness, and those look like, the reason they clump together, the reason the first 3 clump together, we think, is because they're roughly associated with serotonergic function, and the reason the latter 2 clump together is because they're roughly associated with dopaminergic function, and the dopamine system mediates exploratory behavior in the face of the unknown, but it also mediates positive emotion. And it's because in order to move forward into the unknown, it isn't that you have to experience positive emotion, it's that the emotion you experience when you're motivated to move forward into the unknown and explore is a positive emotion. And positive emotion is very much also associated with interaction in the social environment. And maybe that's because a tremendous amount of what you're doing in the social environment is essentially exploratory behavior, right? Because, for example, when you're communicating with people, that's primarily exploratory behavior. So it's not surprising that the circuitry overlaps in that manner. Openness is the one we're going to concentrate on most particularly today. And it's openness to experience technically, and it seems to break down into intellect and openness proper, which is it's intellect, which is interest in ideas, maybe facility with ideas, and openness, which is more like creativity. That's now you can't divide them into interest in ideas and creativity so precisely because they overlap to a great degree, but there is reason for differentiating between them. So, for example, women are about a third of a standard deviation higher than men in openness/creativity, and men are about a third of a standard deviation higher than women in interest in ideas and intellect. And that's actually quite a substantial difference within a trait that's when the 2 traits are so highly correlated. So there's reason to do the fractionation. So anyways, so we're going to concentrate on openness today, and the reason that I'm presenting the trait description first rather than moving immediately into, say, IQ and creativity is because it's useful to know that you can take intelligence and put it in the big 5 taxonomy. And you can actually measure intelligence a lot more accurately with an IQ test, and perhaps also with a creativity test, than you can with the self-report personality test that relies on adjectives. You know, because I could ask you guys, well, how smart are you on a scale of 1 to 7? And that would be roughly correlated with your IQ. But if I really wanted to know how smart you were, roughly speaking, it would be much better to give you an IQ test. And if I was wanting to know how creative you are, rather than asking you how creative you are and getting you to report, even though there would be some accuracy in that, it would be better actually to give you some of the different tests of creativity that we'll talk about today. Now, the weird thing about the big 5, or one of the weird things about it, is that we don't have great tests for the traits independently of self-report for almost all of the traits. So, for example, one of the things that I've been trying to do in my lab for the last 5 years is to find some sort of laboratory task that conscientious people do better on or unconscientious people do worse on. And you'd think that would be simple because conscientiousness, for example, is a very good predictor of long-term life success. It's also a very good predictor of university grades. It's not as good as IQ, but it's still a good predictor. But we have had one insanely difficult time trying to find a non-self-report test that actually predicts conscientiousness. So, much appreciated. Yes.
Could it be that being conscientious has something to do with like being more self-aware? It's hard to test for being self-aware.
No, it's neuroticism. Neuroticism is associated with being more self-aware. And it's actually, it loads on negative emotion. So being self-conscious is associated with being high in negative emotion. I mean, you can assess neuroticism using tests that ask you about anxiety and emotional pain or depression, but that's also not much different than self-report. Anyways, we're going to concentrate on openness today. And we're going to concentrate both on creativity and intelligence. And there's actually almost nothing in psychology that's more contentious, generally speaking, than the investigations into the technical or the set of skills and abilities that falls under trait openness. And the reason for that, and this is especially the case with intelligence, is that intelligence is actually quite measurable. We've been able to measure it since roughly the beginning of the 20th century. Binet originated the first, I would say, reliable and valid IQ tests, and they've been used quite extensively for a long period of time. And IQ, I'll tell you what IQ is as we go through this, but there isn't anything that social scientists have been able to measure more successfully than IQ. And there's nothing that socialists, or very little. There's one exception. The relationship between income inequality and male homicide is a more powerful relationship than the relationship between IQ, say, and general life success, or IQ and general school success. It's even a little stronger than the relationship between IQ and the rate at which you learn something new. But other than that, it's pretty slim pickings. And so we're going to walk through very carefully how IQ tests are created and formulated, and exactly what it is that they measure and why. And we'll equate that to some degree to creativity, and also differentiate it from creativity as well, making the assumption that the aspects of openness, intellect and openness proper, are the proper aspects, and that they're usefully differentiated. So the first thing that you might want to consider is that the world is a very complicated place. Now, we've talked about this before. And the way that you handle, there's way too much complexity for you to handle in its entirety. So, for example, in a room like this, there's an endless number of phenomena that you could focus your attention on, right? From the sort of macro phenomena, which would be the overall, say, color or appearance of the room, to the micro phenomena, which would be the details at the highest level of detail that you're able to perceive, that litter the landscape anywhere. And so one of the problems that you have to solve when you're operating in the world is how you perceive the world. And we do that in part by making, I would say, that we perceive low resolution representations of the world, and we also confuse those with the world. So when I'm looking at you, I'm really looking at what I perceive consciously is a low resolution representation of you, right? I only see the front of you to begin with. I only see your surface. And in some sense, I even perceive you in some sense as a more or less uniform color. It's hard to tell exactly what color skin is. It's sort of a light pink, roughly speaking. But my perception is fairly, I don't know a better way of putting it than low resolution. And I seem to perceive you at the level of resolution that's sufficient, the lowest resolution that's sufficient to facilitate our interactions, because I don't want to clutter up my perceptions of you when we're just talking with excess detail. So there's lots of things about you I don't need to see. I certainly can't see any of your microstructures below the phenomenal level. Like, I can't tell without tremendous further investigation what you're made of biologically, for example. And I certainly can't perceive the networks of society that you're engaged in, your family or the other sorts of networks that you're embedded in. I see you here now, the front of you, at low resolution. And you can tell that to some degree, and we've talked about this before, because if you see, say, animated movies that use very low resolution representations of people, like South Park's a really good example, because the animation in South Park's very iconic and simple. It actually makes almost no difference to following the story. And so that shows you how iconic your perception really is. It can be replaced by very simple icons, and you instantly adapt to that. And so we can go and see the Lego movie, Batman Lego movie, for example, and the fact that it's Batman, which is an abstraction to begin with, and then it's made out of Legos, is almost irrelevant to following the plot. And so some people have compared our perceptions to the user interface on a computer. You know, when you're interacting with your computer, you don't really interact, so to speak, with the computer. There are iconic representations on the screen of the computer that you interact with, and those represent, obviously, they share some functional relationship with what's going on in the computer, but mostly they're there so that you, using your perceptual structures, can interact with the computer in a manner that's easy for extremely intelligent apes, roughly speaking. Now, so one of the problems that you have to solve in the world, because it's so full of detail and so complex, is how do you actually see the world? How do you actually perceive it? And it isn't really self-evident that that's a problem, because you think when you look at the world that it just presents itself to you, but it's a tremendously complicated problem, and that's partly why developing artificial intelligence systems that can actually see the world and act in it in any real way has proved to be a much more difficult problem than people had originally supposed, because we were told maybe from the early 60s onwards that such things as speech to text or object recognition or robots that could operate in the world were only 2 or 3 years away. And well, I mean, we're in a situation now where there are some fairly complicated robots built, but they're still really in their nascent form, and it's because perceiving the world and then figuring out how to act in it turns out to be a much more complicated problem than we originally thought, because the borders between things are not self-evident, and what level of resolution you should be perceiving things at for, say, maximal functional utility is also not self-evident. It's also tied up very strangely and in ways we don't understand with the nature of your embodiment. So for example, we tend to see things that are handy because we can pick them up and manipulate them, and we can make use of them. And so to some degree, our brains are evolved to make the world manifest itself to us in a set of discrete usable tools. That's a reasonable way of thinking about it. And they're discrete and usable because we have a certain kind of biological platform, because we have hands and mouths, and because we walk in a bipedal manner, then it's logical for us to break up the world in a manner that makes operating in this body maximally useful. But that doesn't mean that there's a straightforward one-to-one relationship between our perceptions of things and the things themselves. Quite the contrary. And that's partly, of course, we know that because with any perceptible object, like I could conceptualize you as one thing for all sorts of purposes, but if I'm trying to solve a complex problem in relationship to you, it's going to be very difficult to determine how to conceptualize you. So if you come to me because you're suffering from a psychological problem of some sort, then I have to figure out, is it organic? Is it there's actually something physiological wrong with you? And I need to know what level of analysis I would probably conceptualize you at. Is it psychological? And if it's psychological, is it functional? Like, do you lack the skills, or do you lack the ability to apply the skills? Or is there something really gone wrong with your family? Or maybe it's even a reflection of an overarching sociological problem. We know, for example, that when the unemployment rate goes up 1%, psychiatric hospitalizations go up 5%. And so then you might ask, well, if there's a huge rise in depression and anxiety across the population, and at the same time there's a huge increase in unemployment, you have to ask yourself what level of perception would best be suited to solve that problem, because it isn't self-evident that it's psychological at the level of the individual. Anyways, my point is that perception is a very difficult problem. And so now here's something interesting. You can think about this for a minute. I went and saw an autistic woman speak at one point. Her name was Temple Grandin. She's really worth looking up. Temple Grandin is a very interesting person. She's very seriously autistic when she was a child, but her mother and her worked her out of it so that she's very functional. She works as a professor. I don't remember where. It's in the Midwest somewhere. Now, she's famous not only for being a highly functional autistic person who talks a fair bit about what it's like to be autistic, but also for designing slaughterhouses across the United States. And the reason she can do that, as far as she's concerned, is because she thinks like an animal thinks. And so she doesn't, and she's identified maybe at least part of what the core problem is with autism. So the talk I heard her at was in Arizona, and it was a really an entrancing talk. She showed some really interesting pictures of animals. So what she's done is she's redesigned slaughterhouses so that when the animals enter the slaughterhouse, they go in like a spiral, basically. They can't see what's around the corner, and the walls are high so they're not distracted by anything outside. So one of the things she showed, for example, was a bunch of cows going through a standard sequence of gates, essentially, and off to the side there was a windmill spinning, and the cows would stop because the windmill, they didn't understand what the windmill was, and they'd stop. Or showed other pictures where cows were going down a pathway too, and there was a Coke can sitting in the middle of the pathway, and the cows would all stop because they didn't know what to do with it. Or she had another picture of cows out in the middle of the field all surrounding a briefcase, and they were all looking at the briefcase, and the cows didn't like anything that shouldn't be there and had a hard time mapping it. Now she said, here's a little exercise she did. She said, think of a church. Okay, so maybe you imagine a child's drawing of a church. It's like your standard house, like a pentagon, right? Which is basically how children draw the front of a house, with a steeple on top and maybe a cross on top of it or something like that, which actually isn't at church. It's an icon of a church. And you think about how children draw houses too. Pentagon, rectangle, what is it, trapezoid, chimney, almost always with smoke, which is quite interesting. I don't know where kids get that exactly, but they almost always draw a chimney with smoke, even though chimneys with smoke aren't that common anymore. But anyways, you can see what a child's picture of a house looks like in your imagination. One of the things that you might want to think about is that is not a picture of a house at all, right? It's an iconic representation that's kind of like a hieroglyph, because no house looks like that. And then you think about how a child will draw a person. Circle, stick, 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 stick. And you show it to someone and go, that's a person. It's like, really? It looks nothing like a person, right? You immediately recognize it as a person, but it looks nothing like a person. Well, what Grandin said was that when she thinks of a church, she has to think of a church she's seen. She can't take the set of all churches and abstract out an iconic representation and use that to represent the set of all churches. She gets fixated on a specific exemplar. And she thinks that one of the problems with autistic people, and they have a very difficult time developing language, by the way, is that they can't abstract out a generalized representation across a set of entities. They can't abstract. And of course, if you can't abstract, then it's also very difficult to manipulate the abstractions. And you see very strange behavior with autistic children, for example. So they don't like people. And that's because people don't stay in their perceptual boxes. Like a human being is a very difficult thing to perceive because we're always shifting around and moving and doing different things. Like we don't stay in our categorical box. So autistic people have real trouble with other people. But they also have trouble. So for example, if your autistic child gets accustomed to your kitchen, let's say, and you move a chair, then especially if they're severely autistic, they'll have an absolute fit about it. Because you think kitchen with chair moved. They think completely different place. Because they can't abstract the constancies across the different situations and represent them abstractly. So I made this little diagram. I made this little diagram here to kind of give you a sense of what you might be doing when you're abstracting perceptually. And so you could say, think about something that's that complicated. It's sort of my model of how complex the world is, but the world is a lot more complex than that. But the world is made out of, everything is made out of littler things, and those littler things are made out of littler things, and so forth. And those things are nested inside bigger things, and so forth. And where you perceive on that level of abstraction is somewhat arbitrary. It has to be bounded by your goals. That's the other thing, is that your perceptual structures are determined by the goals that you have at hand. I mean, some of that's not completely true, because your perceptual systems also have limitations, right? There's things you can't see or hear even if you need to. So there are limitations built in, but within that set of limitations, you're still trying to tune your perceptions to your motivated goals. And that's also very useful to think about when you're trying to understand artificial intelligence, because for human beings, without goals, there's no perception. Because there's no filtering mechanism that you can use to determine the level of resolution at which you perceive. Anyway, so there's a thing made of smaller things which are made out of smaller things, and it's kind of my iconic representation of the complexity of the world. And then you could think, well, what is this? How can you see this object? And I think if you just look at it, you can detect, it's like a Necker cube, you know, those cubes that are line drawings that you can see the front of, and then it'll flip to the back. Have you seen those? So this is kind of Necker cube-like, or at least it is for me, in that when I look at it, my perceptions play around with it. Sometimes I focus on the kind of cross-like shape in the middle, and sometimes I can see these other lines, and then sometimes I'll focus on that square, and sometimes I can see the little dots there, or maybe one dot, and my perceptions are going like this, trying to fit a pattern to it. And you can kind of detect that when you're watching it. And so I would say, well, you have the options of perceiving this in its full complexity, or you can simplify it. Essentially, there's lots of ways you can simplify it, but some of them are laid out there. So you take the complex thing, you make a low resolution representation of it. So that's the rough area that all those dots occupy. That's the rough area broken down to its 4 most fundamental quadrants. That might be how you would look at it if this was a map of an orchard and you were trying to walk from south to north. That would be a useful representation. This combines this and this. That's that's the highest level of resolution that you can perceive this object at. That's lower resolution than the object itself. So the first issue is, how should you look at things? Well, that's a problem that intelligence has to solve. So that's one of the problems that intelligence goes after. And then I think what happens is we have the thing in itself, and then we simplify it with a perception, and that's like an iconic representation, and then we nail the iconic representation with a word. And that's how we compress the world's complexity into something that we can manage. We take the complex thing, make it into an icon, and represent the icon with a word. And then when I throw you the word, so to speak, you decompose it into the icon and then decompose it even further into the thing, if you know the icon and you know the thing. And so then we can use shorthand, right? Because you have representational structures and so do I, and I'm just tossing you markers about your representational structures and you can unfold them. That's what you do when you're reading a novel, because the novel comes alive in your imagination in your own idiosyncratic way. And it wouldn't if you didn't understand the references of the novel, right? The novelist has to assume that your basic perceptual structures and your intuitions and your instincts are basically the same as his or hers, because otherwise they have to assume that, because otherwise they would be lost in an infinite regressive explanation. So, and it's problematic often. For example, if you start reading Victorian novels, you may find that it takes a while to get into them because the presuppositions, the expectations are slightly different, and so is the language. You have to update the representations. But anyway, so that's roughly, as far as I'm concerned, that's roughly a representation of what intelligence is doing in the world. Or a big part of it. It's how in the world do you look at things so that you can use them for the purposes that you need to use them for. And then the next problem that intelligence has to solve, which is related, is once you've got the perceptual landscape sorted out, how do you abstractly represent the action patterns that you're going to implement in the world? So it's, how do you perceive where you are now? How do you perceive where you're going? And how do you construct up and then implement strategies that enable you to move from where you are to where you're going? So it's a continual process of mapping and movement. And so it's navigation. That's what we're doing in the world all the time, is navigating through it, because we're mobile creatures. We're navigating through it, attempting to make the world manifest itself in accordance with our wishes. And that's the fundamental problem that intelligence has to solve. And animals have their perceptions to rely on, but we have our perceptions and our ability to abstract from those perceptions multiple times and then to abstract finally into language. So we live in a very abstracted world. And it also means that we can learn a lesson in one place and generalize it across many other places, which is also something that animals have a hard time doing, because they don't know how to do that initial perceptual generalization. So okay, so then the question might be, well, if intelligence has to solve the problem of how to perceive and navigate within the world towards ends, in order to fulfill, in order to make the world manifest what it needs to manifest so that you can maintain yourself and stay alive, what ends is it orienting itself towards? And I think that's a good way of thinking about the traits. The traits motivate the perceptual frame. And so you might think that, well, extroverted people are after social success. And you can understand why that would be, because social success brings with it all sorts of rewards. Social failure brings costs, and you could also understand why that would frighten you away from it. And social success also requires the expenditure of effort, and introverted people seem to be much more conservative in a sense in terms of expending energy socially, and I suppose they're protecting themselves to some degree against the possibility of social failure. We don't really know. We know more about how extroverts, in some sense, how and why extroverts orient themselves the way they do in the world. We're not so sure about introverts. What it is that, what the proper landscape is for introverts. I can show you a word cloud. I'll do that at some point, that introverts, that were generated from introverts on Facebook. And they seem to be into fantasy and gaming a lot. And I don't know why that is exactly, because the fantasy element should be more localized in openness, but the introverted types, I mean, I suppose they're the people that are on the Big Bang Theory, roughly speaking. You know, they seem to be the introverted types, and but we don't understand that much about them, exactly how it is that they're orienting themselves in the world. People who are high in neuroticism are oriented towards security and safety. Agreeable people versus disagreeable people are oriented, say, towards cooperation versus competition. Conscientious people are oriented towards order, duty, obligation, and implementation. And open people are oriented towards abstraction, in both ideational and in representation. And so those are also, to some degree, you might also think about those as value systems, right? Because what you value is definitely not only what you pursue. That's too narrow a view. Value is also what you perceive and pursue. And so thinking about these things as this entire frame of reference, I think, is a much better way of doing it. We talked about this earlier, this sort of structure earlier, as a micro-personality. And I mentioned the determination of micro-personalities by fundamental underlying biological systems like defensive aggression and sexual desire and hunger and thirst and so forth. Those are all systems that can grab your perceptions, make you look at the world in a certain way, make you pursue something else in a certain way, and prime action responses that are in keeping with all of that. The traits seem to be something like higher order agglomerations of those more fundamental biological motivations. Although we don't quite understand the relationship between the underlying biology and the traits, we're starting to sort it out. So we know, for example, if you look at the function of the hypothalamus regulates the basic biological motivations that I just outlined, but it's also the place where the exploratory systems find their ultimate physiological grounding, and openness and extroversion seem to be variant manifestations of the exploratory impulse, and that's grounded in the hypothalamus. So we're starting to be able to put the traits, to sort of nail the traits down to their underlying biology. And with regards to neuroticism, well, if you're high in neuroticism, you're more sensitive to anxiety, and that's regulated at least in part by the hippocampus and generated in part by the amygdala. There's another part of the brain called the periaqueductal gray that seems to be associated with the experience of pain, and pain is quite a complex phenomena. Depression is pain-like, grief is pain-like, social isolation is pain-like, disappointment is pain-like. There's anxiety components to that too. And so neuroticism seems to be something like threshold for activation in those negative emotion systems. So if you're higher in neuroticism, 1 unit of uncertainty might produce, let's say, 3 units of psychophysiological response, whereas if you're lower in neuroticism, 1 unit of uncertainty might produce 1 unit of psychophysiological response. It's hard, you know, obviously that's a simplified schemata, but there's variability because if something unexpected or threatening happens to you, it isn't obvious how upset you should get. One answer might be, brush it off, it's nothing. Another answer might be, it's a bloody catastrophe. And often when something uncertain or threatening occurs, you don't have enough information at your disposal to make a full determination of the potential import of the circumstance, especially if it's uncertain. And so then you have to guess at how upset you should be and where you are on the normal distribution with regards to trait neuroticism, say, that sort of determines what your guess on average is going to be. So, you know, the other, with conscientiousness, say, you might say, well, how hard should you work? Well, that's a really difficult question. If you're going to die tomorrow and then you probably shouldn't work very hard today at all. So one thing you might say is that the degree to which you should work hard is dependent on your assumptions about the stability of the future. We actually know this to be true, because if you put people in wildly uncertain circumstances, they discount the future, which is exactly what you should do, right? It only makes sense to store up goods for future consumption if the future is likely to be very similar to the past and the present. You need a stable society for that. And conscientiousness only works in a stable society, because all you do otherwise, if you're piling up goods, which is kind of what conscientious people do, is leaving them there for the criminals to take, or waiting for the next chaotic upheaval to wipe out everything that you've stored. And so even conscientiousness is a kind of guess. Hardworking people say, well, you know, sacrifice the present for the future. That's great, as long as the future is going to be there and you can predict it. But if it's not going to be there and it's unpredictable, then the right response is take what you can take right now while the getting's good. Now, you know, obviously there are troubles with that too, and I'm speaking, you know, I'm offering rough rules of thumb, but I'm trying to provide you with some indication of how and why these difference in value structures exist, because they're applicable in different environments. You know, sometimes in a dangerous social environment, it's not obvious that being an extroverted person is a good idea, because extroverted people, they stand out, especially if they're extroverted and creative, right? Because not only are they noisy and dominant and assertive, they're also colorful and flamboyant and provocative. Well, that's great if you're in a society that rewards that sort of thing, but if you have, you know, if you're ruled by an authoritarian king who wants absolutely no threat whatsoever to his stability ever, then dressing in gray and shutting the hell up is a really good survival tactic. So the utility of the trait depends on the structure of the environment that surrounds it. And that's why there's variability in traits. And so you have to be careful when you're thinking about it from a strict scientific perspective, to make the assumption that positioning at any place on the normal distribution is preferable to positioning anywhere else. Now, one exception to that might be IQ. Because one of the things that you can see with IQ is that people with higher IQs seem to do better, but that's also only true in complex societies. And then there's another problem that seems to emerge with IQ, and I don't know exactly what to make of this, but we know that as women's IQ increases, the probability that they're going to remain without a mate also increases, because women tend to mate across or up dominance hierarchies. And so if you're a woman with an IQ of 130, then you've already eliminated about 95% of the men. And that's only using one criteria. That's just straight intelligence. And so there also might be limitations to the utility of intelligence with regards to reproduction that we don't really understand very well yet. So anyway, so you get the point. So there's these underlying, I kind of put down two value structures there, capitalize on social groups. That would be an extroverted value structure, say, and maintain order. That would be a conscientious strategy. And conscientious people are going to want to maintain order because they don't want things to shift across time, because if they shift too much across time, then the things that have been stored up for the future start to become increasingly irrelevant. There's lots of other reasons to maintain order as well, but that's one of them. So, all right, so that your cognitive ability allows you to do modeling. Now, this is where human beings have leaped ahead of their competition. So animals can think, but it isn't exactly obvious how they think. They think strategically. I think they think the same way that children think, in some sense, when they're playing with Legos, when they're not thinking about the Legos, you know, when they're just moving them around. We know, like, if you watch a smart predator group like lions go after their target, or watch chimpanzees hunt down a monkey, you can see intelligence at work, because hunting behavior is very, very complicated, obviously, you know, especially if you're chasing something intelligent. But there isn't that level of abstract representation. So let's look at this. So here's a picture of the human brain with someone facing this way, right? So here's the primary motor cortex. Okay, so you're using that to voluntarily move your body. Okay, now then I might say to you, close your eyes and imagine doing something. So just close your eyes and imagine picking up the cup that's in front of you and just visualize it. Okay, so then you might say, well, what part of your brain are you using then? And the answer is use part of this part because that's where you have your body represented. But use this part here, the premotor cortex, to envision potential actions. Now what's happened is that this part of the brain evolved out of this part. And that makes sense because the first part is just how you would move, but the second part is how you would think about how you would move. And then the next part, which is this part, huge in human beings, is how you would think about how you would think about how you would move. So, because that enables you to start to do extraordinarily abstract planning. So I could say, well, envision how you would pick up the cup. And obviously that's something that you've separated out as a potential simulation from the actual action. But we can talk about extraordinarily high-level abstractions that have effects across multiple specific domains way into the future. And the more abstract that your manipulations become, the more they seem to be moved away, say, from the primary motor cortex out into the prefrontal cortex. Hierarchies of abstraction. And the reason for that, as this was Karl Popper, this is really, really worth thinking about. Why think? Let's say you're an animal and you act and it doesn't go very well, and then you die. Well, you've learned that acting that way didn't work, but now you're dead. So that's not that helpful. And then you might think, well, maybe you should represent how you're going to act. So, you know, here's a box with a snake in it, and your coffee cup is inside the box with the snake in it. And I say to you, imagine picking up the coffee cup, and you imagine it, and you think, oh, I'll pick up that coffee cup, and then the snake will bite me, and I'll die. And so then you decide that implementing the strategy of picking up the coffee cup is probably not a very good idea, and so that stupid idea has to die, and not you. And so Popper's idea was that the reason that we developed the capacity to abstract was so that our stupid ideas could die instead of us. And that's really, it's almost impossible to overstate how brilliant an observation that is. Because what it means is that, like, as a standard animal, you would have to produce variants of yourself reproductively to go out into the world and try their hand at survival. And that's pretty costly because you have to produce all the biological replications of you, so you could only probably manage that maybe 13 times if you really, really worked at it. And then the cost of their failure is extraordinarily high because they die. Well, you can just sit there and produce like 20 different versions of you extending out over the next week or the next month, and you can run them through a simulation and kill off all the ones that you don't regard as suitable and then only implement the successful ones. Now, you know, you could debate about how accurate you might be at doing that because it would depend on your knowledge, but we do know that intelligent people tend to do better across the course of their life. And so it does seem that there is some utility with regards to survival, or at least with regards to positioning in the dominance hierarchy, which is somewhat of a proxy for survival and for reproductive success. There's some association between that and the ability to abstract. So we could say that part of the reason that people got smarter was because smarter people were more likely to stay alive. Now, I think it's more complicated than that too, because I believe that human males and females are in an evolutionary cognitive arms race, roughly speaking. And so as men get trickier, women get trickier to understand them, and then as women get trickier to understand, men get trickier to understand them. And so we've been chasing each other around this cortical expansion loop pretty much since we parted ways with the ancestor that we had in common with chimpanzees. And so that's roughly about 7 million years ago. We've undergone a tremendous cortical expansion since then. And there's lots of reasons that have been propelling that. So what do you have to do when you're thinking? Well, you have to figure out where you are and how to see that. You have to figure out where you're going and what that should be. And then you have to generate and represent appropriate action strategies and simulate those in time and space. And then one of the things that's worth noting is that's what you do when you read a story or when you tell a story. And so part of the reason that you like to read stories is because that's exactly what stories are telling you how someone is going about doing that. And so then you can see how, if you think about preference for fiction, which is actually part of openness. Preference for fiction, the utility in fiction is that it allows you to experience a plethora of simulated worlds and to embody the consequences in abstraction without having to go through the trouble of doing that for yourself. And we do know there's good empirical literature now showing, some of it done by ex-students from my lab, showing that reading fiction does improve your interpersonal intelligence, for example, your ability to understand the position of other people, logically enough, because that's what you're doing when you're reading. So, okay, so I'm trying to give you some background so that you can understand what it means to abstract and also why it's useful, because we need that in order to move forward with the idea of intelligence. So here we go. Okay, so that's how you act voluntarily, and then that's how you represent how you act voluntarily, and then that's how you think about how you represent acting voluntarily. And the reason I'm telling you this is because it's useful to think about intelligence as abstract action, because we tend to think about intelligence as abstract representation, right? Intelligence is the manipulation of facts or the understanding of facts. But if you look at it neurologically, I would say that's a misapprehension, because the part of the brain that does the highest level of abstract thinking is actually something that's emerged from the motor cortex. Now, that doesn't mean you don't use your intelligence to represent. You do. But the purpose of intelligence is to represent potential action patterns. And we're embodied creatures and we need to move in the world. And so that's the proper, as far as I'm concerned, that's the proper way to conceptualize intelligence. So, and here's a study. I'll read you the study. Imagery in the premotor cortex. Well, studies on healthy subjects have shown a partial overlap between the motor execution and motor imagery neural circuits. Few have investigated brain activity during motor imagery in stroke patients with hemiparesis. So a partial overlap between the motor execution and motor imagery neural circuits. Well, here's an interesting side consequence of that. So let's say I'm thirsty and I look at that glass of water, and part of what happens when I look at the glass of water is that my eyes activate this directly. So, you know, I've already talked to you to some degree about how your eyes work, right? There's patterns there out there in the world. The patterns are mapped onto the retina, so it's a pattern display matrix. And then that pattern is propagated along the optic nerve, and then that pattern manifests itself in the visual cortex, and then that pattern manifests itself in the motor cortex, and it manifests itself in bodily movement, or preparation for bodily movement. Technically, you don't need conscious imagery for that to happen. Now, that's something really useful to know, is that your eyes can activate your body without you being aware of the image, because you think, there's the world, I see it, then I determine how to act. It's like, yes, but also no. There's the world, and seeing it prepares me to act. Forget about the damn imagery. So when I look at that cup, part of the act of looking at it is preparing that gesture. And that's especially the case if I also happen to be thirsty, because if I'm thirsty, the cup signifies something that I can use to quench my thirst, which makes it a very different thing than what it is when it's empty or when I'm not thirsty. So I'm not even going to use the same part of my brain to perceive it, because it's not the same thing in relationship to me. So I look at it, and then just understanding the size of it, there's not much difference between understanding the size of it and doing this. So, you know, let's see how I got that. So that's pretty good. So that's my when you ask, well, what does it mean to understand something? Well, that's what it means. Insofar as this is a cup, because it could be tinder for lighting a fire, for example, or something to stomp on to make a noise. Insofar as it's a cup, then understanding it means pattern mapping it onto exactly this. And if I do that successfully, then I get a little reward, a little hint, a little kick of dopamine. And that dopamine makes me feel a little bit better, but it also bathes the neural tissue that I use to make that perceptual, to structure that perception, and also to undertake that act, and it makes it just a little bit more likely that I'll see it that way and act that way in its presence again. And that's how you learn, right? You lay out a perceptual scheme, it's got a goal. If the perceptual scheme and its associated action patterns make the goal manifest itself, then you get a little burst of positive emotion, click. then that makes it, those little the neural circuits that instantiated that thrive a little bit and get a little bit more predominant. And that's also why you got to watch yourself if you're taking psychomotor stimulants like cocaine or alcohol even for that matter, because they produce hyper learning. And so, you know, I'll glance at that and maybe it'll trigger off a bit of thirst. But if I was a cocaine addict and that was cocaine paraphernalia and I glanced at it, it was like, whap, that thing that I've built in my head out of repeated, you know, massive hits of dopamine is going to grab my perceptual structures and my actions and bring me, that'll be that craving, which is an impulse to move forward towards it. You'll feel that instantiated in your body. That's the craving. It's very, very difficult to get rid of that. Even if you're a cocaine abuser and you've gone to a treatment center for several weeks and got over the worst of the, at least initial parts of the relearning not to abuse, the second you go back into your natural environment and take a look at the cues, bang, that thing will be right back there directing your action. And what happens is when one of those perceptual systems comes up, you can see this when you're hungry, it suppresses all the other potential perceptual systems. You can see this when you're angry too, right? You get angry and you're angry with your partner and all you can think of is all the stupid things they've done for the last 10 years. You don't even remember that you like them. It's like you could remind them, I know you're mad, but remember you like me. Well, not right now. You know, so it shows you how those micro personalities can dominate and suppress. That's what happens. Because if they didn't suppress the other micro personalities, they wouldn't be able to run themselves to conclusion. And then you'd never get what you want. Okay, so anyways, studies have shown a partial overlap between the motor execution and motor imagery neural circuits. So what happens is you see something and it primes you for the appropriate action. Few have investigated brain activity during motor imagery in stroke patients with hemiparesis. Hemiparesis is motor impairment from the stroke. This work is aimed at examining similarities between motor imagery and execution in a group of stroke patients. 11 patients were asked to perform a visuomotor tracking task by either physically or mentally tracking a sine wave force target using their thumb and index finger. So they're doing this during fMRI scanning. Results: whole brain analysis confirmed shared neural substrates between motor imagery and motor execution in bilateral premotor cortex. So that's the part that I was talking about. I won't tell you about the rest of the brain. Parietal lobule is partly associated with body recognition. So basically, I showed you that study because it's one of the studies that lend credence to what I was just describing, is that imagery is the precursor to action, and that it's associated. You get the imagery going here and the action there. Think about thinking, think, act. That's roughly how it works. Okay, now down to cognitive ability. Well, how can you conceptualize intelligence? Well, this is a major problem because your initial conceptualization determines in part the strategies that you're going to use to investigate intelligence. And when you pare a sentence down to what is intelligence, the sentence is problematic because part of it is a question about if and how such a thing might manifest itself in the world. So there's a fact out there or a set of facts that corresponds to intelligence, but the other problem is, well, what do you mean when you say intelligence? And you kind of have to nail that down if you're going to have a conversation about intelligence that doesn't go entirely astray. And so you've got a definitional problem as well as an empirical problem. And so there have been, and this was especially true in the 1990s, people have been studying intelligence, IQ intelligence, since the 1920s, and it is a very well-established branch of psychology. One of the things I have to tell you about IQ research is that if you don't buy IQ research, you might as well throw away all the rest of psychology. And the reason for that is that the psychologists, first of all, who developed intelligence testing were among the early psychologists who instantiated the statistical techniques that all psychologists use to verify and test all of their hypotheses. So you end up throwing the baby out with the bathwater. And the IQ people have defined intelligence in a more stringent and accurate way than we've been able to define almost any other psychological construct. And so if you toss out the one that's most well defined, then you're kind of stuck with the problem of what are you going to do with all the ones that you have left over that are nowhere near as well defined or as well measured or whose predictive validity is much less and has been demonstrated with much less vigor and clarity. Anyways, despite all that, people have posited a number of different intelligences, and reasonably so, because if you think of intelligence as that which might move you forward successfully in the world, obviously there's a fair number of phenomena that are associated with individuals that might fit into that category. So we have people have made these distinctions. Bob Sternberg, for example, has distinguished between practical versus analytical intelligence, and he kind of thinks of practical as like street smarts and has attempted to dissociate that from the kind of analytical intelligence that that characterizes more straight IQ research. I don't think he's done it successfully as well at all, and since the 1990s, interest in his practical intelligence has declined precipitously, because when it is matched head-to-head with standard IQ intelligence, the IQ intelligence eats up all the variability. What's really happened, as far as I can tell so far, is that when we're trying to predict people's course through life, IQ does a very good job, and then one of the traits does a very good job as well, which is conscientiousness. But it doesn't do as good a job as IQ. Now, that partly might be because we can't measure conscientiousness very well. We're stuck with self-reports, or maybe I could gather peer reports about you, or I could gather your parents' reports about you, or teachers' reports, and each of those seems to pick up a little bit more of the pattern, because you know yourself, but other people know you differently than you know yourself, and there's still some accuracy in that. You can get multiple rater reports of something like conscientiousness, and that'll up its predictive validity. But in the final analysis, the best you seem to be able to do with conscientiousness is about a 0.4 correlation with long-term performance, whereas with IQ, in complex jobs, you can probably get 0.5 and maybe 0.6. And so 0.5 is 25% of the variance. You got to square it. 0.6 is 36% of the variance, and 0.4 is 16% of the variance. So even at the low end, let's say high end for conscientiousness is 0.4 or 16%. Low end for IQ is 0.5 or 25%. Low end estimates of IQ make it 1.5 times more powerful than the high end estimates of conscientiousness. And I think that's about right. You'd think, why do we even have to debate this? And because it's so bloody obvious to me that intelligence is a major predictor of life success. I mean, you people, I've measured the IQ of University of Toronto people. You know, people in this room who have an IQ of less than 120 are rare. Well, why? Well, smart people go to university. Now, is that actually a contentious statement? Well, it shouldn't be a contentious statement. It's self-evident. Universities were actually set up so that smart people could expand their abilities. That's why they were there. And you're selected on the basis of assessments that are essentially there to assess something like intelligence.
Maybe what the controversy is that whatever you're measuring is intelligence. So being able to perform those specific puzzles.
Yes, but that is part of the controversy. Is it reasonable? And this is a measurement issue. And that's why I've been instructing you to some degree in psychometrics, because we actually know how to do this. We know how to answer that question. So let's take a look at how intelligence has been assessed and why, and then you can make up your own mind. Anyways, here's some of the examples of other forms of intelligence. And so then the question is, well, what does it mean to have a different form of intelligence? Would form A and form B be completely uncorrelated? Like extroversion, say, in neuroticism, or would they be slightly correlated, or would they be highly correlated? And then you might ask, well, how highly correlated do they have to be before they're the same thing? Or how uncorrelated do they have to be before they're different things? And actually the answer to that comes down to something like practical utility. It's like, imagine I'm trying to figure out how well you'll do in university. And I measure one thing, and it's correlated at 0.7 with another thing I measure about you. Then I might say, well, are those two things the same or different? They're pretty highly correlated. You're high in one, it means you're going to be high in the other. Well, so is there any utility in measuring both things? And the way you figure that out actually is you do it statistically. So we take the target, which might be your performance across university. And then we say, well, can we predict your performance across university better by using one variable or two variables? So we would enter them both into a regression equation. All a regression equation does, it's quite simple. So you're trying to predict the target, and the regression equation tells you how well you can predict that target if you know another fact. Now then it gets a little complicated because that's a correlation. How well you can predict B with A. Well, a regression will say how much you can predict C if you know A and B, or A and B and C and D and E, because you can use multiple predictors, and you can weight them. So it might be 2 times A plus 1 times B equals C. And that's all a regression equation does. It's just multiplication and addition. Very, very straightforward. And so two variables are sufficiently different functionally if you can use both of them simultaneously to predict something of interest. So again, it's a tool-like approach. This is how the psychometricians do it. Is something real? Well, it's real if you can measure it and it helps you predict. That's how it's defined. So then you might say, well, are there these multiple intelligences? Well, the first question would be, well, what do you mean by are there? And the answer to that would be, well, let's specify the question. Since we're going to be scientific about it, let's predict how well people do in university. We'll start with the assumption that intelligence, if intelligence isn't associated with university success, then you're probably not talking about intelligence. Now you could argue that, right? Because you could say, well, intelligence has nothing to do with university success. But that's a definitional matter. We'd have to agree to begin with. Is it reasonable to start with the presupposition that intelligence and university success share something in common? Well, I think you have to be daft to deny that initial proposition, although you could. Because you could say it was privilege or socioeconomic status or any number of sociological phenomena, and some of those are obviously relevant. Social class, for example. Because, you know, if you're in a higher social class, and all things being equal, intelligence included, if you're in a higher social class, you're more likely to go to university than you are if you're in a lower social class. So there's other factors that are going to influence whether or not you do well in university, but we're going to assume that one of them might be intelligence. Well, then you would ask, well, if you measured social intelligence, so that's, what do they call that? Social intelligence? No, emotional intelligence, which does not exist, by the way. Emotional intelligence, moral intelligence, linguistic, musical, logical, mathematical, spatial, body kinesthetic, interpersonal, and interpersonal. All different forms of intelligence. Okay, so to answer the question of whether they exist, what you do first is pick a target, prediction of university performance. Then you make a measure for each of them. Then you test to see if the measure measured the same thing across multiple instances within the same person. That's a reliability test, because what the hell good is your ruler if it stretches when you use it? It has to measure the same thing multiple times. And then you would say, okay, we'll take all these different intelligences measured the way we've decided to measure them. The first thing we'll do is see how highly correlated they are, because if they're two of them are completely correlated, then you have one, you don't have two, because that's virtually the definition of one instead of two. You can factor analyze them and see if you can pull out what's common across all of them. That's another thing, because then you might say, well, intelligence is what's common across all the measures of these intelligences. It's a proposition, it's not a fact. You have to decide if you're going to agree with it. But that, if you were going to do that, you'd use a factor analysis. You'd say, well, if someone was more likely to be musical, if they were also high in linguistic ability, and more likely to be logical and mathematically inclined if they had high spatial ability, etc., then you'd be hypothesizing that there was one factor behind all of those manifestations that's somehow similar. And maybe there wouldn't be. And then you'd take all your measures and you'd put them in something like a multiple regression analysis, and you'd predict your target, university performance.